Good morning. Good morning, Akshita. In our last class, we discussed what all things we discussed is what is irrational number, what is an irrational number, three types of decimals: terminating, non-terminating, but repeating, non-terminating, also non-repeating. So these are the three types of decimals we have seen. In that, these two are called rational numbers, and this kind of decimals are called irrational. So we also have seen the definition of an irrational number, that is which cannot be written. This is the proper definition for irrational number, which cannot be written in P by Q form. This is irrational. Now we have seen some examples. Root 1, root 2, root 3, root 4, root 5, root 6, root 7, root 8, root 9, root 10. Among these, which have the proper answer? Root 1 has proper answer, root 4 has proper answer, root 9 has proper answer. So whichever has proper answers, those are called rational numbers. Yes, you will get answer for root 1, you will get answer as 1 is rational. For root 4, you will get answer as 2 is rational. For root 9, you will get answer as 3, that is rational. Other than these, remaining all things are irrational numbers. So these are the examples we have seen. Also in last class, we have seen how root 2 is irrational. Just 1-2 minutes I will repeat the procedure. What we have thought is, let root 2 is equal to P by Q. Imagine that it is rational, and then we have squared it on both sides. Then 2 will become equal to P square by Q square. So P square is equal to 2Q square. From there we concluded that P square is an even number. If P square is an even number, implies P is also even number. If P is an even number, then we can take P is equal to some 2k, because it is a 2 multiple. Now, therefore, substituting P is equal to 2k in this equation, we will be getting 4k square equal to 2q square. From there, we will get 2k square equal to q square. We are also getting that q is an even number. See, when we have taken that root 2 is equal to P by Q, here itself we declare that P and Q have no common factors. There itself we declare it. But now after proving this all things, we got P is even number, Q is also an even number. That means P and Q have common factor as 2. That means our assumption is wrong. Therefore, root 2 is irrational. Clear? Now, going ahead, this is the last thing we stopped our class. Now we are going to see, please put the heading as some useful results on irrational numbers. some useful results on irrational numbers. In that, result 1, is negative of an irrational number. Negative of an irrational number is also an irrational number. Negative of an irrational number is also an irrational number. Example, root 2 is irrational because there is no proper answer for that. Implies minus root 2 is also irrational. Yeah, there are also negative numbers in irrational numbers, positive and negative. So root 2 is irrational, then minus root 2 is also irrational. So like that, root 3 is irrational, minus root 3 is also irrational. Root 10 is irrational, minus root 10 is also irrational. So that is result 1. Going for result 2. Result 2 is sum of a rational and an irrational number. Sum of a rational and an irrational number is irrational. This one, how you can remember is very simple. I'll just give you an example, then I'll say you my own analogy for this. See, 2 is rational and root 2 is irrational. If you add these two, you will be getting another irrational number. You cannot call it rational. Why? See, root 2 is 1.414 something, going to be non-terminating, non-repeating. Now 2 plus root 2, it is going to be 3.414, non-terminating, non-repeating. Therefore this is also irrational. I think you got the clarity. Now my own analogy I wanted to give you. There is a good boy. Okay, there is a good human being plus bad human being. There are 99% chances that the combination will together become bad human. Right? Yeah, 99%, because the bad has a lot of strength over good. Good is like, a small creeper which you have to protect it very carefully. But bad is like, big tree which can uproot anything actually. It will not allow the creepers to grow. So this is something like rational, this is something like irrational. When you add it, again you will get irrational. This is a small analogy which I wanted to give you so that you can remember it for a long time. Okay, result 1 is negative of irrational number is also an irrational number. Result 2, sum of a rational and an irrational number is irrational. Shall we go to the result 3? Yes. Result 3. Product of non-zero rational number and an irrational number. Product of non-zero rational number and an irrational number is again an irrational number. Is again an irrational number. So here you might get a doubt, Akshita. Why you have highlighted non-zero? See, I'll give an example to you. Can you give an example for a rational number? Let's take rational number 3. Now you are multiplying 3 with root 2. This will become just 3 root 2. 3 into root 2 is just 3 into, you can't write anything. Actually, since root 2 is irrational, this will also become irrational. 3 into root 2 also you do, you will get non-terminating, non-repeating decimal only. Kitna bhi kar sakte, you cannot change it. But now I am giving another example. 0 into root 2, answer is 0. It's rational. 0 is a rational number. That's why they have used the word non-zero. Is that clear? Product of non-zero rational number and an irrational number is again an irrational number. 0 is rational. Therefore, we have to be very careful. Rational number into irrational number will give you irrational other if rational number is non-zero. Okay. Now, result 4. Okay, result 4 is something important. One second. Sum, difference, product and division or quotient, both are same, of two irrational numbers, of two irrational numbers need not be an irrational number. Sum, difference, product and quotient of two irrational numbers need not be an irrational number. Why? Means need not be matlab it can be or it cannot be. First of all, I'll give examples for sum. Let's take root 2 plus root 3. Both are non-terminating, non-repeating decimals, and like both are like root 2 plus, both are in addition. Root 2 plus root 3, answer is nothing. You cannot write it as root 5. No, actually it's wrong. It's not root 5. It will just remain like root 2 plus root 3. You cannot mix oil and water. No? Like that you cannot mix root 2 and root 3. The answer is just root 2 plus root 3. It is irrational. So when you added two irrational numbers, again you got irrational. See, when you add root 2 plus minus root 2, we read in the result 1 that negative of irrational number is again irrational. Therefore, root 2 is irrational, minus root 2 is irrational. Both of them we are going to add. So when you add two irrational numbers, you are getting here root 2 get cancelled 0. That is rational. So sometimes it can be irrational, sometimes it can be rational. That's why they have used the word need not be. Clear? Similarly, let's see it for subtraction. Root 2 root 3 minus root 2, again they are not mixable. No, answer will remain just root 3 minus root 2. You will be getting an irrational number. But root 2 minus root 2, subtraction of two same irrational numbers, you will get 0. That is rational. Clear? Next, multiplication. Root 3 into root 2, root 3 into root 3. See, root 3 into root 2, you can take root common, and 3 into 2, 6. Root 6 is irrational, right? Here, root 3 into root 3, that is root 3 into 3, 9. Root 9 is 3 again. So that's going to be rational. So sometimes even in multiplication, you are getting rational, sometimes you are getting irrational. So even that is true with division also. So result 4 is very important. Sum, difference, product and quotient of two irrational numbers need not be an irrational number. Correct? Let's do some problems. Okay, let me see whether recording is happening properly. Yes, it's happening. Let's do not some problems, plenty of problems to get our understanding right. Write down question 1, or you put the heading example 1. identify root 45 as rational or irrational. This is our question, Akshita. So root 45, you should identify it like either rational or irrational. So root 45 can be written as 9 into 5 or 15 into 3, but 9 into 5 is much useful for us. Now root of 9 into 5 can be written as root 9 into root 5. Okay, root 9 is 3, root 5 is irrational. So just before, in our rule, we learned product of a non-zero rational number and an irrational number is again irrational number. Therefore 3 is a non-zero rational number, root 5 is a irrational number, and multiply these two, the answer is irrational. Therefore root 5 is irrational number. Is that clear? It should be. Next, example 2. Insert irrational and an irrational one second, Akshita. Insert a rational and an irrational number between 2 and 3. So between 2 and 3, we need to insert a rational number and an irrational number. I told you rational numbers and irrational numbers are so friendly that between two rational numbers you can find infinite irrational numbers. Between two irrational numbers you can find infinite rational numbers. So first of all, our job is to put rational. Very simple. 2 key 3. Between 2 and 3, the middle value is exactly 2 plus 3 by 2, it is 2.5. Yes, 2.5 is inserted. That is a rational number. The first job is done. Now what we need to insert is a irrational number. So 2 can be written as root 4, 3 can be written as root 9. So in between not one irrational number, you can put root 5, you can put root 6, you can put root 7, you can put root 8. Any one of these can be your answer because they are not perfect squares. So these are all irrational numbers. So you can put root 5, you can put root 6, you can put root 7, you can put root 8. Anything you can insert as irrational number. Clear? Now, next example. This is the last example for the class. Find two irrational numbers. Find two irrational numbers between 0.12 and 0.13. 0.12 and 0.13, you have to insert two irrational numbers. So what time we will use the technique of, you remember Akshita, I told you 0.101, 001, 0001, 000001. This is also irrational number because nothing is repeating, pattern is not there. So that is the same technique we are going to use. So 0.12, 101, 001, 0001, 401, 501 and so on. This is one such rational number. Let's call it A. We can put another one, 0.10, 01, 011, 0111, 01111, 4 ones, 5 ones, like that. You can insert many more. So A is irrational because it's non-terminating, non-repeating. B is also irrational. It is also non-terminating and non-repeating. So A and B are two irrational numbers among infinite. Two irrational numbers between 0.12 and 0.13. Is that clear, Akshita? I am stopping the class over here. Please revise the notes before coming to the next class. Thank you.